Our planet's climate is a complex system. It's a delicate interplay of many factors. These factors include the sun's energy, Earth's atmosphere, and our planet's oceans. The climate has changed throughout Earth's long history. Natural cycles play a crucial role in these changes. Understanding these cycles is key to comprehending the current state of our climate. For millennia, Earth's climate has fluctuated between warm periods and ice ages. These shifts are influenced by natural processes. These processes involve Earth's position in space and its internal dynamics. Today, however, our planet faces an unprecedented challenge: human-induced climate change. The scientific consensus is clear. Human activities are altering Earth's climate at an alarming rate. We are already witnessing the consequences. These consequences include rising sea levels, extreme weather events, and disruptions to ecosystems. Understanding the interplay between natural cycles and human influence is crucial. We must address this global challenge effectively. Earth's journey around the sun dictates the rhythm of our seasons. Our planet's axis is tilted at approximately 23.5 degrees. This tilt causes different parts of Earth to receive varying amounts of sunlight throughout the year. When the northern hemisphere is tilted towards the sun, it experiences summer, while the southern hemisphere experiences winter, and vice versa. The Earth's orbit around the sun is not perfectly circular, but slightly elliptical. This means that Earth's distance from the sun varies throughout the year. However, the effect of this variation on our seasons is minimal compared to the influence of Earth's axial tilt. Beyond the annual cycle of seasons, Earth's orbit undergoes subtle but significant changes over thousands of years. These changes, known as Milankovitch cycles, are driven by the gravitational influences of the Sun, Moon, and other planets in our solar system. These cycles affect the amount and distribution of solar energy received on Earth, influencing long-term climate patterns. There are three main Milankovitch cycles: eccentricity, obliquity, and precession. Eccentricity refers to the shape of Earth's orbit around the Sun, which varies from nearly circular to slightly elliptical over periods of about 100,000 years. Obliquity describes the tilt of Earth's axis, which fluctuates between 22.1 and 24.5 degrees over approximately 41,000 years. Precession, as mentioned earlier, is the wobble of Earth's axis, completing a full cycle roughly every 26,000 years. These cycles act like a celestial dance, subtly altering the amount and distribution of solar radiation reaching different parts of our planet. These variations can trigger shifts in Earth's climate, leading to glacial and interglacial periods. While Milankovitch cycles influence Earth's climate over millennia, other natural phenomena such as El Niño and La Niña exert their influence over shorter timescales, typically every few years. These events, collectively known as the El Niño Southern Oscillation, ENSO, involve fluctuations in sea surface temperatures in the tropical Pacific Ocean, leading to significant impacts on global weather patterns. El Niño is characterized by unusually warm surface waters in the central and eastern equatorial Pacific, while La Niña features unusually cool surface waters in the same region. These temperature anomalies disrupt the normal atmospheric circulation patterns, leading to a cascade of effects felt worldwide. During an El Niño event, the Pacific jet stream strengthens and shifts southward, bringing increased rainfall to the southern United States and South America, while causing droughts in Australia and Southeast Asia. Conversely, during a La Niña event, the Pacific jet stream weakens and shifts northward, leading to drier conditions in the southern United States and wetter conditions in Australia and Southeast Asia. These shifts in precipitation patterns can have profound impacts on agriculture, water resources, and ecosystems. Understanding ENSO is crucial for predicting seasonal climate variations and mitigating the impacts of these powerful natural phenomena. Section 5. Polar vortex and jet streams, weather extremes. High above Earth's surface, powerful winds circle the poles, trapping frigid air within their swirling embrace. These winds, known as the polar vortex, play a crucial role in regulating global weather patterns. When the polar vortex weakens, it can allow frigid air to escape southward, bringing bone-chilling temperatures to lower latitudes. The polar vortex is influenced by the jet stream, a fast-flowing river of air that circles the globe from west to east. The jet stream acts as a barrier, separating warm air from the tropics from cold air from the poles. However, when the jet stream weakens or meanders off course, it can allow the polar vortex to bulge southward, leading to extreme cold snaps and winter storms in regions unaccustomed to such frigid temperatures. Climate change is altering these factors, leading to a more erratic jet stream and an increased likelihood of extreme weather events, including heat waves, droughts, floods, and winter storms. Section 6. Geomagnetic reversals, a flip in the field. Deep within Earth's core, molten iron churns and flows, generating a magnetic field that surrounds our planet like a protective shield. This magnetic field, known as the magnetosphere, deflects harmful solar radiation, safeguarding life on Earth. However, Earth's magnetic field is not static. It fluctuates in strength and even reverses polarity over time. Geomagnetic reversals are natural events that occur over irregular intervals, averaging about every 200,000 years. During a reversal, Earth's magnetic field weakens, allowing more solar radiation to reach the surface. While the exact consequences of a geomagnetic reversal are still debated, some scientists believe that increased radiation exposure could disrupt satellite communications, power grids, and even pose risks to human health. While there is no evidence to suggest that a geomagnetic reversal is imminent, understanding these events is crucial for assessing potential risks and developing mitigation strategies. Section 7. The solar cycle, our star's rhythmic pulse. The Sun, our nearest star, is a dynamic and active celestial body. Its surface is a cauldron of boiling plasma, threaded with magnetic fields that twist and turn, unleashing bursts of energy into space. These solar storms, while awe-inspiring to behold, can have tangible impacts on Earth, disrupting communications, power grids, and even posing risks to astronauts in space. The Sun's activity waxes and wanes over an approximately 11-year cycle known as the solar cycle. During solar maximum, the Sun's magnetic field is at its strongest, leading to increased sunspot activity, solar flares, and coronal mass ejections, which are powerful bursts of plasma and magnetic field that can travel through space at high speeds. During solar minimum, the Sun's activity is subdued, with fewer sunspots and solar storms. Understanding the solar cycle is crucial for predicting and mitigating the impacts of space weather. Section 8. The lunar nodal cycle, tides and time. The Moon, Earth's celestial companion, exerts a powerful gravitational pull on our planet, influencing the ebb and flow of tides. However, the Moon's orbit is not perfectly aligned with Earth's equator, causing its gravitational influence to vary over time. This variation is governed by the lunar nodal cycle, a celestial dance that unfolds over approximately 18.6 years. During the lunar nodal cycle, the Moon's orbit oscillates, causing its gravitational pull on Earth's oceans to strengthen and weaken over time. This fluctuation influences the amplitude of tides, making them higher or lower than average. The lunar nodal cycle can exacerbate the impacts of sea level rise, particularly in coastal areas already vulnerable to flooding. Understanding this cycle is crucial for predicting extreme tides and mitigating the risks of coastal erosion and flooding. Section 9. Human impact, a call to action. For millennia, Earth's climate has been shaped by natural cycles, but now a new force is at play: human activity. Since the Industrial Revolution, our relentless burning of fossil fuels has released massive amounts of greenhouse gases into the atmosphere, trapping heat and warming the planet at an unprecedented rate. The evidence is overwhelming. Global temperatures are rising, ice caps are melting, sea levels are surging, and extreme weather events are becoming more frequent and intense. The consequences of inaction are dire, threatening the delicate balance of our planet's ecosystems and the future of humanity. We must transition away from fossil fuels and embrace clean, renewable energy sources. Let us heed the warnings of science and embrace the opportunity to create a sustainable future for all.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.